Okay, in this video I'm going to talk about the parallelogram formed by the midpoints of the sides of a quadrilateral. So basically we have an arbitrary quadrilateral, it can be any quadrilateral, and we take the midpoints of the sides of this quadrilateral. So basically we take the midpoint here, the midpoint here, midpoint here, and the midpoint here. And basically the theorem is that the quadrilateral, like with the vertices in these midpoints, is a parallelogram, regardless of the original quadrilateral. The original quadrilateral can be any quadrilateral, and this quadrilateral would be still a parallelogram. So let's denote the points. So the theorem is that MNKL is a parallelogram. Is a parallelogram. So basically the proof is quite simple. So let's consider the diagonal AC and the triangle ABC, right? In the triangle ABC, MN is like a line connecting the midpoints, right? The two midpoints of the two sides of the triangle, and we know that we know that such line is parallel to the side of the triangle, and it is equal to half of this side. So like in any triangle, like if you have a triangle and these midpoints, so like ABC, MN, that then we know that MN is parallel to AC, and MN is equal to 1/2 of the AC. This is simply because the triangles MBN and ABC are similar with the coefficient 2. So like, or another way to put it, if we consider homothety, like scaling of the plane with the center B, it's called homothety, with the center B and with the scaling coefficient 2, then the M maps to A and N maps to C, and the whole triangle MBN maps to the triangle ABC. But like in any case, this is a pretty standard theorem. It's well known that these two properties hold. So similarly, we consider the triangle ACD, right? In the triangle ACD, like let me draw it separately. So in the triangle ACD, we have the midpoints of the sides K and L, like this, and similarly we have that KL is parallel to AC, and KL is equal to 1/2 of AC. So now we look at this and look at this, and particularly from the parallels, so like from this and this, we conclude that Mn, so Mn is parallel to AC, which is in turn parallel to KL. So all these three lines are parallel to each other, and so Mn is parallel to KL. And from these two equalities, we conclude that Mn is equal to 1/2 of AC, which is equal to KL, right? So in other words, Mn is equal to KL. So Mn is parallel to KL and Mn is equal to KL. So these two sides. From this, it is already enough to conclude that MNKL is a parallelogram, but we can also establish similarly, like if we consider the other diagonal BD and consider the triangles BCD and BAD, like similarly we can establish that NK is parallel to ML and NK is equal to ML. So let's write this. So similarly, NK is parallel to ML, and NK is equal to ML. So basically, this quadrilateral MNKL is it has the opposite sides parallel to each other and equal to each other, and it is well known that this is a parallelogram. So from this, well, from it is enough to conclude from this, but like by the definition of parallelogram, like we can conclude it from this and from this. So this and this implies that MNKL is a parallelogram. And this concludes the proof.